Hello, my name is Giles here, and right now we're about to go over a physics two-dimensional problem. As you can already tell, this physics problem is going to occur with the cat that starts off from the table, jumps at an angle, and lands on the floor. Maybe I can give you a better illustration of what we're going over if I can actually bring up one of the study materials close to you. Dun dun dun! Physics problem. So this is going to be about a cat that's jumping from the table and lands on the floor. And basically what they want us to do, they want us to calculate the max height that the cat could possibly get to, the time it took, and the distance. So with that being said, let me go ahead and show you how I would begin to solve this problem. So with the question being a cat jumps off a table at 85 centimeters at 5 meters its initial second at an angle, usually you're going to have three questions that come along with this problem. Some of the three questions would be maximum height, time, and distance. So right now, what I'm going to do, I'm going to put max height. Now, in order to solve or to begin, we're going to have some physics formula here. So one physics formula that we should be going over is x equals x initial plus vt, v equals v initial plus at, v squared equals v initial squared plus 2a delta x. And I'm going to put one more as the displacement, VO2 plus yo. So right now we have about 4 equations right here. So in order to calculate what I would like to see, the maximum height, let's go ahead and utilize this problem right here, which is going to be the formula, physics. So from here we go v squared equals v initial squared plus 2a delta x. Now notice how I grabbed the physics formula and put it exactly the way it was. So with this, you want to go ahead and deduct the v initial squared to get on the other side. You now get v initial squared minus v squared. And then you're going to have 2a delta x. Go ahead and bring 2a over. And once you rearrange this, you should be left with a delta y equals v squared minus v initial squared 2a. Now, I'm really glad the way this worked out. As you can tell, the formula that we need for the max height is here, and it's next to our other physics formula. So we're going to have 5 right now. From here, let's go ahead and plug in the necessary components. As far as delta y is concerned, we're going to go ahead and do v squared sin data squared minus v initial squared sin data squared. As you guys recall in class, the reason why the v squared and sin gets squared is because of the v initial squared. So meaning that sin has to get squared, and the reason why we're using sin is because of the height of that angle. Now, from there, just go ahead and plug in with the information that you know. 5 squared sin 53 squared minus 5 squared sin 53 squared all over 2a. Now with sin 53, it gets treated as parentheses, meaning that it needs to get completed first. So with this right here, because I know with the v velocity initial is going to be at 5 meters, we think the final and that's going to be 0 squared. So 0 squared multiplied sin 53 is going to come out to be 0 minus 5 squared is 25. Sin 53 is 0.798. However, it still needs to get squared. And once it gets squared, it becomes a different number. 2a is 2g, which in reality, you're going to have, and if I can just continue going, 0 minus 25.638, because the exponent sin 53 had to be squared, 2g, and you guys know the formula for gravity is going to be 9.81. And don't forget, gravity is going down, so it's not a positive number. Now from there, keep going as the rules apply accordingly. 0 minus, this should be at 15.92, and this should be at a total of 19.62. Now, a lot of people get confused. The only way to move it in physics whenever you have the 0, is to get rid of it. I've seen several different ways. You can go ahead and enter this in a calculator. 0 subtract 15 will give you negative 15.92. You can do the old-fashioned rule. Turn this into a plus sign, turn this into a negative. That will get you negative 15.92. Or what you can just do is just literally take the 0 away, and you will see you left with the minus number, 15.92. And then you see you have 2g at the bottom, which is going to be 19.62. And now remember that this is going to be a negative number, and this could be a negative number, which in return gives you a positive number, 0.81. Now, as the formula for that one goes, h1 plus h equals hmax. So 0.81 plus the original height problem, 0.85, will actually give you 1.66. If you really want to, you can go ahead and round that up, and you will get the answer, 1.7 meter. Now, that's going to be it for the maximum height. We left with the answer at b squared. Now, for the quadratic formula, if I can bring you guys' attention over here, quadratic formula, you're going to be using this physics kinetic formula, and this becomes the a squared, this becomes the b squared, and this becomes the c squared. Now, another formula you need to know for the quadratic formula is the actual, and I'm going to go ahead and do it my way, negative b plus or minus square root b squared minus 4ac all over 2a. From there, go ahead and begin exchanging the values that you know. For the a squared, it's going to come in this, so it's going to be half g. For the b squared, it's going to go in this part. And for the o, it's going to be this part. So let's go ahead and start solving. And remember, this is at an angle. So basically, we're going to, a squared is going to be half g. B squared is going to be v initial sin data. And c squared is actually going to be the h, which is the height, and which we know is going to be at 0.85. So if I were to go ahead and solve this, what I'm going to do is start plugging in the information I know. Negative v initial sin data plus or minus sin data plus or minus square root v initial squared sin data squared minus 4 the g and the h all over 2a. Now from there, we can go ahead and begin v and start putting in the actual values of the number. So the first one's going to be negative 5 sin 53 plus or minus all the way down 5 squared sin 53 squared minus 4, and you got the half g, which is going to be at negative 0.49, and you got the h, which is going to be 0.85. Now from there, all you have to do is just begin and continue solving. Sin 53 becomes 0.798. 0.78 times 5 becomes 3.99. Let's go ahead and round that up to negative 4. Five squared becomes 25. Sin 53 becomes 0.798. Remember to square 0.798. When we square that, it becomes 0.638. 0.638 times 25 becomes 15.92. Negative 4.9 times 4 becomes negative 19.62 times 0.85 becomes negative 16.68. Negative 15.92 subtract negative 16.68 gives you a square root of 32.68. The square root of 32.68 is going to be at 5.7. You got negative 4, and then you have plus or minus. Then you're going to have 2g, which is going to be the 2a, which is going to be 2 half of g, because that's what goes into the formula a. And then you're going to be left with, right here, a negative 9.81. Now, from there, if you were to go ahead and do negative 4 plus 5.7, you get 1.7 divided by negative 9.8, which gives you negative 0.018. From here, negative 4 subtract negative 5.5, 0.7 gets you negative 9.7. Negative 9.7 divided by negative 9.81 gives you the positive seconds of 99. Now, a little bit of a secret. We're always going to use the positive number here. So this can be the number for seconds. The negative 18 doesn't really go to waste. All it is for this part right here, which is calculates this back part. Now, from there, all we're going to have to do is just gather the exact precise distance. So one question is going to will be, what is the max distance? To get the max, and I'm going to put d, distance, we're going to be using this formula. X equals x initial plus vt. The x initial is actually 0. It's at an angle, so it's actually going to be 5 cos 53 multiplied by time. 0 plus is going to take the 0 away, so then we get in return cos 53 is actually going to be 0.60 multiplied by 5 will actually get you 3.0. 3.0 multiplied by time will actually give you the answer of 2.97 meters in distance. So here I got one answer, I got the second answer, and I got the third answer. So by going over this physics problem, we were able to gather the maximum height it took, the quadratic formula to grab the time, and we also were able to get the distance precisely. So this is how you do a physics 2-dimensional problem. My name is Giles. Please let me know if you have any questions at all, and I hope this really worked out, where you guys got a chance to learn about physics from a 2-dimensional problem, and you guys have more information on the field of general physics. Thank you.